Hey everybody, welcome Mustangs to first video of Algebra 2 here with me. Don't forget to like and subscribe to my YouTube channel, No Hair, No Problem. You'll notice that in these videos, I got a really shiny head. So throughout all my videos, you'll notice that I have a tendency to make videos where I wear stuff on my head just to kind of take away from some of that shine. But that's all right, no hair, we have no problems. But today I'm going to be doing our notes over the very first objective of this year, which has to do with positive exponents. And an exponent is just a shortened way of writing something that's much larger. So for example, if we look at, let's review what we should know, that if I had like 3 times 3 times 3 times 3 times 3, that's a really long way of writing a simple concept, right? That really there's 5 of these 3's involved. So we could say it's 3 to the 5th power, okay? If I was to say x to the 6th power, we can extend that out into what we call expanded form, and that would be x times x times x times x times x times x. There's 6 x's there, okay? So let's start talking about rules that we know when we're dealing with exponents, okay? And there's several of them to know. They're pretty straightforward, but just kind of use them as a guide when we're going through things. So first rule, when we're talking about zero exponent rule, it says that if we have anything, literally anything to the 0 power, it's just going to equal 1. Now that rule is actually, it comes from the division rule, which I'll get to in 1 second when we get back down to division at the bottom here where it says division rule. But anything to the 0 power, excuse me, holy smokes, that's equal to 1. So literally 5 to 0 power equal to 1. A to 0 power equal to 1. 4/3 to 0 power, it's equal to 1. Everybody always wants to say it's equal to 0, but it's not. It's equal to 1. If I go in Desmos here and I put in my favorite number, whatever my favorite number is, doesn't even matter. I'm going to put in 13, which is not working at the moment here. And I'm going to put in 13, and I'm going to raise it to the 0 power. I get a 1. If I put 5, raise it to the 0 power, I get 1. Anything to the 0 power is always going to simply equal 1. Okay? The second rule that we have is the multiplication rule. Real simply, here's what we're going to do. If I take multiplication, I want you to watch what we do. Multiplication, when we're dealing with exponents, we're going to take the exponents and we're going to add them together. Okay? Again, if we have multiplication going on with exponents, we're going to simply add those exponents together. Okay, now what do I mean by that? So if we have x to the a times x to the b, what that's going to equal is a plus b. That multiplication will turn into addition. Okay, so when we look at this one, it's 5 to the 3 plus 7, which means we get 5 to the 10th. Now why is that? Well, that's because when we look at this first part here, that 5 to the 3rd power is the same as saying 5 times 5 times 5. It's like saying 5 3 separate times. When we look at the second part where it says 5 to the 7th, that's like saying 5 times 5 times 5 times 5 times 5 times 5 times 5. Okay? And there's a total of 7 there. When I put all of those together, this entire thing, all of it together, you can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those 5s. So we say 5 to the 10th power. Okay? So if we were to apply these rules, looking at the first one here, we would have a to the 5 plus 4, which is a to the 9th. If we look at the next one, there's 3, 6, and there's actually an exponent right here that's not written. There's a 1 right there. Okay? So if we write this out, it's going to be 7 to 3 plus 6 plus 1. So this will be 7 to the 10th power. When we look at the next one here, there's nothing I could do. Now, why is this? Because when I look at this 3 to the 5th, that's a 3 times 3 times 3 times 3 times 3. So there's 5 of them. And then there's a 7 times 7 times 7 times 7, which is, there's 4 of them. I can't put this together. I don't have 3's and only 3's and 7's and only 7's. I've got 3's and I've got 7's. So I will keep this exactly as it is. I got 3 to the 5th. And 7 to the 4th. That's it. That's all I can do, unless I wanted to multiply it out. Okay? All right, 2 more rules to go over here. exponent rule with division. What this says, okay, you ready? If I have division, watch what's going to happen here. If I have division, division turns into subtraction. Okay, division turns into subtraction. Okay, what do I mean? What's going on? Well, let's change this so that it's x to the a minus b. Well, why would this be the case? Why would I subtract? Why would this subtraction or this division sign right here turn into subtraction right here? Well, here's why. When I look at this first one here, the 7 to the 10th is like writing out 7 10 separate times. 7 times 7, that's 6, 7, 8, 9, 10, right? The 7 to the 4th power is like writing 7 4 separate times. So now what I'm going to do is think about what each one of these actually equals. What is 7 divided by 7? It's just 1. So these go away. Do it again. What is 7 divided by 7? It's just 1. 7 divided by 7 equals 1. 7 divided by 7 equals 1. And so I'm able to take and eliminate each one of those, which leaves us now, when you look at this, there are exactly 6 of the 7s, and there's more on top than there are on the bottom. So when we look at this, 7 to the 10 minus 4 means that we have 7 to the 6th power. Okay? So now let's quickly get through these. A to the 8 minus 3 equals a to the 5th. This is 10 to the 12 minus 3, which is 10 to the 9. And then there's a 1 on this next one here, so this will be x to the 5 minus 1, which is x to the 4th. Okay? All right, now, when we have power to a power, I got the power. I got the power. Just me. All right, so when we have a power raised to another power with these, what we're going to do now is we're going to take these and we're going to actually multiply these. So this will be a times b. Why do we multiply? Well, take a look at this one right here. Let's first deal with the inside part here, which is x to the 3rd power. Okay? Looking at just that x to the 3rd power is like saying we have x times x times x. There's 3 x's there. When I say let's raise it to the 4th power, what I'm saying is let's go ahead and write this exact scenario. I'm going to copy it, and then I'm going to paste it. There's 1. There's 2. There's 3. And then there's 4. So I got 4 of them. So I've got 3 x's, but I've gotten rid 4 separate times. And when I look at this and I put it all together, we can see that there are a total of 12 of those x's in the problem. So how do we get that with our shortcut? We simply say x to the 3 times 4, which is x to the 12th. Okay? So look at this next one. Let's go ahead and just keep it real simple. This will be 2 to the 5 times 3, which is equal to 2 to the 15th. This next one, now these get a little more challenging, okay? We're going to break this into separate problems, okay? We've got a to the 3rd to the 5th. We've got b to the 5th. That 5 gets distributed to everything in here because it's all inside there. And then we've got a c to the 2nd to the 5th. Okay? So that means we've got a to the 15th, b to the 5th, and c to the 10th when we multiply those exponents together. All right? One more problem here. That 5 will go to each one of these, and we're going to have 3 to the 5th, a x to the 4th to the 5th, which means we're going to get 243 x to the 20th. Okay, now let's do this one out the long way so we can see what this really is. Okay, just for this inside portion, that 3x to the 4th, here's what it actually means. We have 3, here, let me do it in green. We have 3x, x, x, x. There's one of them. All right, you ready? we're going to make it so there's 5 of them. So duplicate, there's 1, there's 2, there's 3, there's 4, and then there's 5. Let's just throw it over here. There's 5. Okay. So when I take all of these 3s and I put them all together, that 3, 3, 3, 3, and 3, that's 3 to the 5th power. So when we look at that, that's a total of 243. Okay. When I look at all of my x's, I think to myself, my God, I have a lot of x's. Must have dated a lot in my life, right? Just kidding. All right, when we look at all these x's, there are a total of 20 x's there. But there's 5 separate times. So there's x to the, there's x to the 20th power. Okay. That concludes this session of notes. Please let me know if you have any questions or if you need any further assistance. Just know that they do get a little more challenging, but please reference these notes whenever you have questions. Take care of yourselves. Don't forget to like and subscribe to my channel. You take care, Mustangs.